Okay, good afternoon, grade 12s. Question 1, November 2023, but the chemistry paper. Question 1, paper 2. Okay, so which one of the following represents a straight chain saturated hydrocarbon? So now you haven't studied, so you don't know the difference between saturated and unsaturated, which is fine. I just want to show you, if you know every carbon needs to have 4 bonds. So let's draw the first one quickly, and the second one, and the third one, 2, 3, 4, 5, 6, and the fourth one. So this is a bit of a waste of time. It would be better if you had studied, but I'm talking to those of you who haven't. If it's C5H8, it's 1, 2, 3, 4, 5, 6, 7, 8. It's nowhere near enough hydrogens in order to give every carbon 4 bonds. So A must have a double or triple bond in it. I'm not even bothered where or how or what, but there's not enough hydrogens. Then if I do the second one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Also not enough hydrogens. So this word must mean that the compound has enough hydrogens. It must mean that it is an alkane. It must mean that it is an alkane because 2 of the examples had not enough hydrogens, which means what I'm looking for is obviously something that has all of its hydrogens. What I'm looking for is an alkane. I'm looking for CnH2n plus 2, which you were supposed to have studied, but what I'm trying to show you is that you actually didn't need to. So if you just carry on, so the first 2 definitely not, then the third one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Not enough. So this one must be it. I can show you that it is. But otherwise, you can just draw them. And you don't need to know what saturated versus unsaturated means necessarily. If you just draw them, this last one is the only one that has all of its carbons having 4 bonds. So that one is the only one out of the 4, so that one must be the answer. If you can't work out what it is, you can work out what it definitely isn't. So this is hexane, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Hydrogens for 6 carbons. Okay, so if we look at the next one, you've got which one of the following is a secondary alcohol. This is maybe a bit more tricky. I think you would have had to study this. But a secondary alcohol, if you can remember, or if you've ever heard of it before, the carbon that the OH is attached to 2 other carbons. So this situation will be happening in the alcohol. So if we look at our first option, it's that, which if I draw it, it's a it is a carbon with 3 CH3 stuck on it. So 3 CH3s are stuck on it, and there is an OH on it. There's 3 things here and another thing here. This one carbon has 4 things bonded to it because carbons need 4 bonds. So that the carbon that the OH is attached to 1, 2, 3 other carbons. It's not that one. Secondary means that the carbon that the OH is attached to 2 other carbons. So let's just check the next one, if I can at some point. Okay, so next one, well, I'll just put them all there. So the next one is CH3, then it's CH2, CH2, CH2. So this is sometimes quite tricky, but the difference between this and this carbon has nothing else on it. It's just a carbon, which means these 3 things plus this thing must be attached directly to that carbon, because the main rule, guideline, doodad thing of organic is that every hydrogen must have 4 bonds. And maybe also what you're not seeing, these are CH3s. This is a CH3, it's a methyl group. What is here is a CH2. CH2 is in the chain, CH3 is attached to the chain. CH2 needs 2 extra bonds, CH3 only needs 1. So again, you're maybe not going to recognize this, but it's just from doing hundreds of years of organic, you would eventually get to know it. But here's this one, that one there is this one here. Then there's 3 carbons in a row, and then there's an OH. The carbon that the OH is attached to must be attached to 2 other carbons. This one is only attached to 1. So this thing is actually primary. This one was tertiary, if you know what that is. This is not an alcohol. So again, this is maybe a bit tricky, but I don't know. An alcohol is OH. It's got a hydroxyl group, so it's definitely not that one. I don't even need to do anything with it. It's definitely not that one, because that is not even an alcohol. So therefore, it's going to be D. I can draw it for you. You don't need to. It's CH3, CH2, CH, CH3. The CH3s are at the end. They only need 1 bond. This guy has got 1, 2, 3 bonds. That one needs the OH. The carbon that the OH is attached to 2 other carbons. That is a secondary alcohol. C was not an alcohol, can't be that. And the other 2 were alcohols, they just weren't secondary. So if you could follow any of that, the multiple choice, you need to answer them all. Please don't leave any of them out. I mean, if you run out of time or something, just write anything. If they say there's 1 minute left, you can do your entire multiple choice by just doing A, B, C, D, A, B, C, D. Don't leave it out. If you leave it out, it's definitely wrong. If you write any of the letters, you have a 25% chance of getting it right. Please don't leave it out. Anyway, so that one was D. That one is D. Number 3 is going to be under here somewhere. Which one of the following is a hydrolysis reaction? So this is a bit of an English lesson. Hydro comes from water. And lysis is, if you do life sciences, it's when something dies or pops. So basically, not that one and not that one. Well, it's a hydrolysis reaction. Water is a reactant. So now, immediately, we are guessing between 2 rather than 4, which is obviously better. This one is making water. It removes the it removes the OH, and it adds a Br. So B, this reaction, is making the OH, it's turning an alcohol into an alkyl halide. It's turning the alcohol into something that has a halogen on it. It's swapping OH for Br. A is swapping Br for OH. This one is hydrolysis. You are using water to break the Br off and put the OH on. So A and B are kind of opposites. A is hydrolysis, is the one that we want. This one is halogenation of an alcohol. So this one we're adding a halogen, so it's got halogenation, halogen in the name. This one we're adding water, so this one has got hydro or water in the name. The other 2, this one is hydration, you're adding water. The first 2 are substitution reactions. You've got 2 reactants making 2 products, substitution. 2 reactants making 2 products, substitution. You should know that hydrolysis is a substitution reaction. So if you could know that, you would know that A and B are your only options. C is addition because it's 2 reactants make 1 product. And D is also an addition reaction because 2 reactants make 1 product. So if you know anything about reactions, you should know that hydrolysis is a substitution reaction, 2 reactants, 2 products. Okay, then 1.4 is based on reaction rates, which is normally question 5 in the exam paper. Hydrochloric acid reacts with excess zinc, so you've got more than enough zinc. And they say different reaction conditions are shown in the diagrams below. The mass of the zinc used is the same in both test tubes. So the mass of the zinc is the same, but the surface area of the zinc is different. So this one is a powder and this one is lumps. This one also has a larger volume of the HCl. This one has a smaller volume of the HCl. So let's see what our options are, what the actual question is. How will the initial rate of reaction and final volume of H2 produced in test tube Y compared to test tube X? So step 1, be very careful about the headings here. What is going on in this table? They're asking about the initial rate of Y and the final volume of hydrogen in Y. This G shouldn't be a capital. They're saying that hydrogen is a gas. So if you have a higher volume of HCl and the HCl is not in excess, the zinc is in excess, you are going to make more hydrogen gas from this one than from X. And you can kind of see that in that they only gave you options of equal or more. But again, what we're trying to do is just guess better, kind of. So it's not C and it's not A, because test tube Y will definitely have more hydrogen gas because it has more HCl. C is equal to N over V. And so whatever the concentration is, if the volume is double, you're going to have a bigger N. And if you have more of this, you're going to make more of this, logically. So it's definitely more for the final volume of the hydrogen gas. And in test tube X, the initial rate, so what is the difference in the rate between Y and X? The rate is going to be lower because this is lumps. This is kind of, I don't know whether you guys have ever had a grandpa powder as a painkiller. The powder works faster than the tablets, simply because the surface area of every single tablet is bigger so that you can absorb it faster. The same works in reactions. The zinc powder mixes better with the acid, allowing reactions to happen. If you've done reaction rates at all, you know about collision theory, and you need sufficient energy, which has got to do with the temperature, but also correct orientation. And you're going to get more effective collisions with the powder than with the lumps. The lumps first need to be broken down into powder for the reaction to speed up a bit. So the initial rate of the reaction in Y is going to be slower because it's lumps, but you will make more hydrogen gas because there's more hydrochloric acid, number of moles, in test tube Y because the volume is bigger. Okay, 1.5, it's now a KC question, which is typically question 6 in the exam. It is question 6 in the exam. It says the diagram below represents a mixture of NO2 and N2O4 at equilibrium in a 1 decimeter cube container at a temperature of T. They give you the balanced reaction and they ask you about the equilibrium constant. We need to know that Kc is equal to the products, the concentration of the products divided by the concentration of the reactant. Now they've made me make it slightly easier because the volume is 1. So if you do C equals N over V, basically C and N are going to be the same because the volume is just 1. But anyway, we need to count. Sorry, I don't know how we feel like that, but then we just color in the NO2s quickly. So how many of these do we have? It doesn't really need to be accurate, I suppose, but let's just try and do it properly. They are saying it's either going to be 24, more than 1, equal to 1, or basically less than 1. It cannot be less than 0, that's just silly. But NO2, I've just counted now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 of those, and there's 1, 2, 3, 4, 5, 6 of those. 6 over 12-ish, just as a thing, it's going to be less than 1. It must be D. So 6 over 12 is going to be less than 1. It's a half. Basically, there's less product in this reaction than there is reactant. So because there's more reactant, the Kc is smaller. It's less than 1. So basically, this would not really be an option. Normally you have Kc either bigger than 1 if the forward reaction is favored, or smaller than 1 if the the reverse reaction is favored. 24 is a bit of a random number. I don't know where they got that from, but I don't know how you would get that. Maybe they should have done 72 instead, which would be 6 times 12. But anyway, I hope you can see here the amount of product is less than the amount of reactant, so the Kc value will be less than 1. The Kc value is not going to be less than 0 though. It's never going to be negative because you can't have a negative amount of product or a negative amount of reactant. Okay, so then for 1.6, we've got another KC question. So let's see what they get for that. So for 1.6, they say a reaction is at equilibrium in a closed container according to the following balanced equation, and the volume of the container is now increased while the temperature remains constant. Which one of the following combinations is correct for the new equilibrium? So they have increased the volume and kept the temperature the same. So now, again, if we know anything about KC, if the temperature remains constant, the KC will be constant. So immediately A is out. So if we're guessing, A is immediately out, because if the temperature remains constant, the equilibrium remains constant. The equilibrium constant remains constant. This thing depends on temperature only. Also, we need to take note, that is a solid and that is a solid. So if we increase the volume, what we've done is decrease the pressure. If you guys did grade 11 at all, you would have done PV equals nRT, and P and V are on the same side of the equation, so that means P is inversely proportional to V. If you don't like that, if you squeeze a balloon or squeeze a soccer ball or a tennis ball, or not really a cricket ball, if you squeeze a balloon, that's increasing the pressure, the balloon will get smaller. Increase the pressure, decrease the volume, or in this case, we are increasing the volume, so we are decreasing the pressure. And if you've done Le Chatelier's principle at all, if you make the pressure smaller, the reaction will want to increase the pressure again to cancel out the change that you made. And in order to increase the pressure, I need to make more gas. This is a solid and this is a solid. So those two will not affect the pressure, but O2 will affect the pressure. So you need this to increase in order to make the pressure get bigger again, because what we did by increasing the volume, what we did by increasing the volume made the pressure decrease, and so now the reaction wants to increase the pressure again by making more gas. So the number of moles of oxygen will definitely increase, and the concentration of the oxygen gas. So now they've made the volume bigger, but the thing is they made the volume bigger, so C equals N over V. So if you make this number bigger, the concentration should decrease, but because you are favoring the forward reaction, you are also making this number bigger. So the volume is getting bigger, which makes the concentration smaller because they are inversely proportional. However, you are also making the number of moles bigger. So basically, if I can show you, maybe mathematically with numbers it would be better. If in the beginning this was 2 over 2, if you make them both bigger, for example, double them both, 4 over 4 is the same as 2 over 2. 6 over 6 is the same as 2 over 2. So if you increase both of them, the concentration will remain the same. So for this one, the answer is C, because the concentration won't decrease, because you've increased the volume, but you've also increased the number of moles of the gas. Okay, so 1.7 is for acids and bases, and what they say is that nitric acid and ethanoic acid of equal volumes and concentrations are compared. Now, you need to remember, in general, HNO3, HCl, H2SO4, those are the strong acids. So those three are strong. So this is a strong acid. All of the organic acids are weak. But if you can just remember these three are strong, any other acid you can assume is weak in general. Consider the following statements. They will both have different pH values. The pH of the strong acid will be lower than the pH of the weak acid. Both will have the same electrical conductivity. Okay, so that sounds a bit scary, but basically what they're saying is both of them will ionize the same. Both of them will form ions to the same degree, which is also, that is not true. That is not true because a strong acid will ionize completely to form a high concentration of H3O+. A weak acid doesn't do that. So they don't have the same electrical conductivity. And then it says both solutions require the same number of moles of KOH for complete neutralization. That would be the same. That will be the same because both of them only make one H. HNO3 has one H over here, which will donate as an acid. Vinegar or ethanoic acid has only one H, which will donate as an acid. So the number of H's that each of these acids has to donate is the same, and they would both require the same amount of KOH. So the OH from the KOH will react with the H from the acid, and they would both need the same number of moles because they have equal concentrations and equal volumes. So what that is saying is equal concentrations and equal volumes means they have the same number of moles. So they'll have the same number of moles. So that means, if we just look here, which of the above statements are true? It's going to be the first one and the third one. And if you can't do that, it's definitely not the second one. So if you can just know that it's not the second one, that immediately deletes two of your answers. And, I suppose, again, sorry, I'm trying to encourage guessing, but it's just guess smart. Because you can't guarantee getting however many marks for multiple choice, but please never leave them out. And if you even it's actually better maybe to leave multiple choice till the end, because sometimes you end up wasting quite a lot of time, because I speak through it and it takes me 10, 20 minutes. You can't really take 20 minutes to do 20 marks, although I suppose you could. It's just sometimes it takes you guys even longer. And when it gets to the last 5 minutes, if you have issues with time, you can easily just go A, B, C, D, A, B, C, D, A, B, C, D. Well, you have to do it a few more times, but you can easily do that in the last 2 minutes of the exam rather than trying to answer a question on galvanic or electrolytic or any other section. So this is the easiest section to do quickly, and if you can just delete some of the answers just to guess smarter, it's easier to guess between 2 than 4. Anyway, 1.8 is about acids and bases as well. It says the apparatus in the diagram below is used for the titration between HCl and KOH. Now, again, I don't know whether you know, but I wrote here the 3 strong acids. This is a strong acid. KOH is a strong base. Strong bases, it's if they have group 1 metals. So KOH, NaOH, LiOH, all of the ones with group 1 metals. On the periodic table, the first column is group 1. If they have a group 1 metal with an hydroxide, it is a strong base. So this is a strong acid and a strong base. And they say, in a titration, the learner accidentally exceeds the end point. Which one of the following will be true? So if they had done it correctly, the pH would have been around 7, because it's strong acid and strong base. However, they've now added extra HCl, which should lower the pH. The pH should be less than 7. So if we look at our options, the pH should be less than 7. So again, if we are guessing, it's not that and it's not that, because both of those say the pH is more than 7. And HCl is an acid. It donates a proton. So therefore, there will be more protons present than hydroxyls, because the acid has been added in excess or too much acid. So the answer for this must be A. You have extra H pluses because you have extra acid, and the pH is less than 7 because a pH of less than 7 means acidic. Okay, so 1.9 is on galvanic cells, which is normally question 8 in the paper. It says, consider the following statements for this galvanic cell. So now I just brought one of these here. If you can see, if you use table 4b, it's always top right, bottom left. The anode is on top and the cathode is at the bottom when you're doing galvanic. So top right, bottom left. And now for this galvanic cell, they want you to consider the following statements. They say the EMF of the cell is 20 volts under standard conditions. So now they told you that this was a galvanic cell. And when you do the calculation for the EMF of it, what you do is you take the cathode, which is at the bottom, and you subtract the anode, which is at the top. So the formula is given on your formula sheet. I don't want to get this wrong, but it's something like this. Cathode minus anode. So that will be the one at the bottom, which is typically positive, minus the one at the top. So the one at the bottom and subtract the one at the top. So in this case, normally you would do 0, 0,10, and then you would subtract the negative one. Sorry, 0, comma. So this is correct. I is correct. Again, if you look at this table, the anode is on top, and the anode is the one that has a negative value, normally. So if they both have a negative value, it's going to be a bit tricky, but the one that is the most negative in terms of this number here will be the anode in a galvanic cell. So electrode Y is the anode. That will be true because when you compare both of them, the Y is the negative one and the X is the positive one. So the X will be down here somewhere where the positive numbers are, making that the cathode. The other things you need to know, anox, the anode is oxidized, and red cat, the cathode is reduced. So basically, if you know anything about anything, 2 and 3 can't be true. So if we look at this, we can cross out D immediately. There's typically always one that you can immediately cross out. 2 and 3 cannot be true together. And electrode Y is the anode. That is certain because if I look on my table that I'm given in the exam, I can see that the numbers on top are negative and the thing on top is the anode when I'm using table 4B. So electrode Y is definitely the anode. And so number 2 is definitely true. So therefore it makes it B. So number 1 you actually didn't even need to look at. So you know it's not D. Number 1 is in all of them. So therefore number 1 must be true. And then you know that electrode Y is the anode because it's on top. If you put it in this table, it would be on top because its value is negative and X's value is positive. The negative values are on top in table 4B and the anode is always on top if you're using table 4B. Now for the next one, it's probably going to be electrolytic. It is. Which one of the following half reactions below will be the main reaction at the anode in the electrolysis of CuCl2? So now, when we do electrolysis, it's often the opposite of galvanic. So if I can just look here, what we need to do is, we are talking about concentrated CuCl2. So if I can just move that up a bit to get out of the way, clean off a bit. Okay, so move this down. Come on, guys, please. Please, please, please. So basically what we're reacting here, it's concentrated CuCl2. Cl is 1 minus. There's only one reaction on here that has chlorine in it. There's quite a few versions of copper, unfortunately, but here's the one for chlorine. So you maybe want to spend some time just looking at this table, because if you know how to use this table, there's a lot of stuff you don't need to study, actually. So often the charges of the anions and cations, you can just get them from the table rather than remembering them. But that is the reaction for chlorine. The other one, copper, must be 2 plus. Chlorine is 1 minus, and there's 2 chlorines. So chlorine is 1 minus, and there's 2 chlorines with the copper, so copper must be 2 plus. So I'm looking for copper 2 plus. And in order to have a galvanic or an electrolytic cell, you need solid copper. So I know I have copper 2 plus, and I know I need solid copper, so then it must be this one. If we just want to look quickly, the reason why I'm doing all of this, there's Cu2 plus, but this is Cu plus. You cannot have a solid electrode made of Cu plus, because Cu plus is going to be dissolved in solution. It's an electrolyte. And then there's another one here with Cu plus and Cu. So copper is a bit tricky, because there's 1, 2, 3 of them, but this one that I've highlighted in blue is the one that we use most often. And in this case, we have Cu2 plus because chlorine is 1 minus. I know that because I've learnt it, or I know that because I can find it on the table. Chlorine is in group 7, so everything in group 7 becomes 1 minus when it becomes an ion. Well, most common charge for group 7 will be 1 minus. So now, if we're looking at this, we want to look at the main reaction happening at the anode. So we don't really want to look at the waters, because it's concentrated CuCl2. So we're either going to do this one or we're going to do that one. We found them both, which is great. This one is going that way, and this one is going that way. We started with Cl- and Cu2+. So Cu2+ is becoming copper, and Cl- is becoming Cl2. They ask which reaction is going to be the main reaction happening at the anode. So now for galvanic, I told you that the anode is at the top. That's only true for galvanic. The anode is actually at the bottom of table 4b when you're doing electrolytic. What is always true is the anode gets oxidized. So this reaction is going from right to left. This is an oxidation reaction because electrons are being released. So if there's another one for oxidation is loss of electrons, so you're making electrons. Reduction is gain. You're getting electrons. So if you can't tell that the chlorine is losing electrons, maybe you can tell that the Cu2+ is getting them. The Cu2+ and the 2 electrons add together to make solid Cu. So maybe that one's easier to tell. So anyway, with all of that, this answer would be D, because this reaction here is the anode. How do I know? Because this reaction here is where it's getting oxidized. The anode is always oxidized. However, on table 4b, the anode is on top for galvanic, and it's actually at the bottom for electrolytic. I have made a summary of all the things to do with galvanic and electrolytic. I'm pretty stoked about my little summary. I'll look at it again in question 8 and 9. But here's everything that is true for galvanic. Here is everything that is true for both of them. And this is true for electrolytic. So the galvanic is a spontaneous reaction. The electrolytic is non-spontaneous. However, the anode is always where oxidation occurs. So the anode is always oxidation. It's true of both. The galvanic is chemical to electrical energy. The electrolytic is electrical to chemical energy. But the cathode is always where reduction occurs. And the oxidation reaction is from right to left on table 4b. I must maybe add that. So all of my things are compared to table 4b, which is the one we were using in the previous question. Table 4b is the one that I use, and all of this is based on that. Here is the reactions that they were just talking about in that question. I've put them here just in case. There's concentrated brine, molten NaCl. Brine is salt water. Molten NaCl is just liquid table salt. So these are all given here. You can study them. You can also derive them from the table. This little story here we're going to deal with in probably question 8. So I'll bring this up again in question 8 or 9. It's got a lot of information on here. There's a lot of information on here. And so if you're doing question 8 or 9, maybe either copy this down or get the copy that I gave you in class. Obviously, if you're not in my class, that doesn't help you. But I do think that this is quite a good one. It tells you everything you need to know. They've even got this reducing agent gets oxidized, and oxidizing agent gets reduced. So again, I'm talking specifically about table 4b though. If the electrode loses mass, it's the anode. If the electrode gains mass, it's the cathode. So bubbles don't count. Bubbles isn't gaining mass, and it's not to say that the cathode always gains mass. That is not necessarily true, but if one of the electrodes is gaining mass, that will be the cathode. So I'm not saying that the cathode always gains mass, but if one of the two is losing mass, that will be the anode. The cathode doesn't always gain mass, if you want to think about it like that, but the cathode never loses mass. Just one last thing I want to point out here. I call these Terry tables of my class. It's basically if you can remember any one of these points. So what I choose to remember is that in the electrolytic, the anode is positive. I remember that. There's something about cats being positive or something, so the cathode is positive in the galvanic. But your job is just to remember any one of these. So I remember that the anode is positive in the electrolytic. I always remember that. So therefore I know that the cathode is negative in the electrolytic, which means the cathode is positive in the galvanic and the anode is negative in the galvanic. So if you put it out like this, There were quite a few of them that I went through for the physics paper. There was one for newtons, there was one for Doppler, there was one for circuits. But if you remember this, you just need to remember one of the 4 instances, and then you can derive all 4 of them from that one.